Hello, hello, hello. Welcome back, guys. Today is Saturday, the 16th of May. I love how, like, every single time I say a date now, I'm like, surprised, because it's a different day than I would normally be streaming. But, welcome to exam season. The schedule is so in flux, like, people moving here, there, and everywhere. And it's like, all right, guys, when we can grab it, that's when I'm going to fit you in. Hello, hello, hello. So, I'm hoping you guys can feel it, because I can feel it. We got, like, exams are very much upon us. So CP1, for those of you doing further math, you've already done your first of them. I've just messed my entire calendar up. Let me fix that. So that was on Thursday. I've heard kind of mixed things. So I've heard the Edexcel CP1 was very, very good. I've heard the OCR MEI was, like, weird. OCR was kind of like, A was kind of straight down the middle. So yeah, I've definitely heard, like, mixed things about how that went, but it means that exam season is upon us, which means as well that we have our physics paper 1. I'm looking at that. That's on Wednesday. And have I had time to go through, like, the entire syllabus? No, but I think I've left some okay stuff for the end. So we've got materials to do today. Looking at my textbook I got down here, I left pretty much the whole of, like, in the AQA syllabus, section 3. So, like, the forces, motion, and energy. Because I thought if there's anything to leave, that's okay to leave, because that's the one that's kind of like GCSE plus. But the new thing there is materials. And I've seen some comments dropped. And in the Discord server, people were like, yeah, do materials. So I just wanted to make sure I got that covered in this final session before you guys have to use it in the paper 1. So, hold on, let me get... Because also it is exam season, which means I am not as prepped as I would normally be. So there shall be a textbook right here, and everything will be fine. Now, luckily, by the way, materials was actually my degree. So if you guys have any extra questions, feel free to drop them in the chat, and we'll see how much of my degree I've completely forgotten. Oh, it's going to be one of those days, guys. One of those days. I'm just throwing the pen around here, there, and everywhere. So, calm my energy down. Exam stress. Oh, you can just... guys, I'm so nerdy. I just live for exam season. The energy just gets me. And that's how you know I am in the right profession. So, first things first, we start off nice and simple. In fact, let me not even share a screen for this. So, the first thing you talk about is density. And I think density, you guys are super familiar with. Density is mass of an object over the volume of that object. That's kind of GCSE stuff. Now, there's two ways of working. The mass, you work out super simply. You put it on a scale top balance, measure the mass that way. Volume, you've got your two methods. You either work out the volume mathematically if it's a simple shape, like a cube or a sphere, or you can use the water displacement method, where you fill a measuring cylinder up part way, read the initial volume of water, drop the object in, read the new volume of water. The change in that volume of water that's measured is equal to the volume of the object you dropped in. So you get your mass, you get your volume, you divide them, you get your density. That's all fairly self-explanatory. What is less self-explanatory is how to combine densities. So let's say, for instance, we have an object A. So object A is going to have, like, a mass A, it's going to have a volume A, it's going to have a density A, where the density of A is equal to the mass of A over the volume of A. And if we do the same thing with object B, we have a mass of B, a volume of B, a density of B, then we know that the density of B is the mass of B all over the volume of B. Now let's say we take these two objects and we kind of combine them. What would be the overall density? Well, that would be nice and simple, in that the mass would be equal to just the sum of the individual masses. The volume would be equal to the sum of the individual volumes. And so the overall density would be the total mass all over the total volume. But we can kind of get rid of these masses, but because we know that the mass of A is equal to the density of A times the volume of A, and that becomes density of B times the volume of B all over the total volume. And in other words, what that means is it's the density of A times A's what we would call like the volume fraction, where this VB over V would mean, so this V is the total V. So VB over V would be the sort of percentage volume that B occupies. So in other words, it's kind of, in fact, you can think of this as being very similar. If you do chemistry, this is very similar to you finding out the atomic mass, right? Oh, why is my mic glittery? By glittery, I think you mean glitchy. What's happening there? I definitely selected the right microphone. Please pause. I'm going to unplug it and then replug it and hope everything goes okay. Let's find out.